All right, does this work? Can everyone hear me? Yeah. All right. Hello, everyone, and thank you very much for coming to our talk today. I'm going to be talking about building large language model-based agents and how you can build smart NLP-driven applications with Haystack. But before I get into that, a bit about myself. This is my first time here in Salt Lake City and at PyCon, so I am a bit nervous and excited. I hope this goes well. My name is Tuana, and I'm the developer advocate at DeepSet, which is the company behind Haystack, the open source tool we'll be talking about. I have a background in computer science, but have been doing DevRel since about 2020. All right, so today's talk is going to follow roughly this structure. At the end of the day, I kind of want to pass on the message around how agents even became, how they were possible. Then we're going to look into a bit about what Haystack is, how you can interact with large language models using Haystack, and then we're going to see how we might create our own agents with Haystack. There is going to be a bit of coding towards the end, and also, just a side note for everyone, given that this is about natural language processing, there is a lot of language on the slides. If you cannot see the text, I will be reading out the ones that are most necessary, because we will be looking at some fairly long prompts, and we'll see what that is later as well. All right, so without further ado, here is a brief history of the how humans search, let's say, according to me. So it's not very accurate. And this is more about how humans extract information. So we communicate with each other, that's great. Then we have books, then we have the World Wide Web. And quite recently, I'm pretty sure without me having to tell you the exact name, a lot of us have been relying on a very well-known NLP technology. So I want to start explaining to you how agents even came about, how they work, the idea behind them, giving an example of some interactions I might have with this NLP technology. There are some memes in this slide deck. You can blame that all on Jasper over there. That's my colleague who gave me the feedback that your slide deck needs memes, so there you go. All right, let's start with some examples about what we can do with large language models. Let's start simple, and here is that interface I'm pretty sure a lot of you have already seen. This is simply a question. So we know we can ask questions to large language models. And we've got back a pretty accurate long answer. So that's one thing we can do. Here I've asked who was the first president of the USA, and I got a correct answer, quite a detailed answer. That's great. But the one thing to notice here that this is a question. What else can we do? Well, we can ask it instruct these large language models to do something. This is not necessarily a question to be answered. Here I've highlighted around my instruction, which says, summarize the following text for me. And I've simply copy-pasted the answer that I got before. And this is where you start to see how things are getting different. I'm instructing the large language model to do something for me. And I've got a pretty accurate summary. These models are generative, so you don't necessarily have to ask it for information. What's cool, you can also ask them to create content, create previously non-existent content. So you can achieve beautiful literature a bit like this too. Here I say, create a PyCon event schedule in the style of a poem, and it's beautiful. It knows about tutorials, it knows about talks, keynotes, etc. It's a pretty good poem. But then the next two slides is where I want to really draw your attention to, because this is where really the whole idea, the essence of agents come about. I know I've just started saying agents without actually having asked you, do you know what I'm talking about when I say agents? But hopefully you'll start to get an idea what they are. All right, so this is the first instruction. This one is different because I've basically imagined up two things, which I'm going to be calling tools. And I said, you have the following tools, PyCon event QA, and I've explained what it's useful for. I've said useful for when you need to answer questions about PyCon. And then I've also said you've got web search, and I've said it's useful for when you need to search the web to answer general questions that other tools cannot. And then I've given a query saying, pick which tools you would use to resolve the following query. When is Tuana's talk at PyCon? and what is the weather at Salt Lake City going to be like that day. And I've only asked it to pick the tools based on the descriptions I've given. And what I want you to notice is that it has picked the right tools in the right order according to what is deduced that it has to learn, it has to find out. So that's one thing to keep in mind. The next one is quite long, so if anyone in the back cannot read this, don't worry, I'm going to highlight what's the most important part of this one. It is the same prompt, the same instruction. I haven't said prompt yet. Okay. It is the same exact instruction with one key difference. I have added a line saying, explain step by step how you arrive to your conclusion. This is often referred to as the chain of thought methodology. This is where we can ask the large language model to reason about why it's picking some tools. And the response, I want to really draw attention to number 2 here, which says, once I have located Tuana's talk in the PyCon schedule, I would note the date and time of the talk. So you can see it's making decisions around what information is going to be important for the next tool. Now, agents really, in essence, is this. The only difference is the tools do actually exist. This question here is going to be recurring throughout my talk. When is Tuana's talk at PyCon, and what is the weather going to be like at Salt Lake City on that day? Because I've gone ahead and built this agent, and at the end of this talk, what we want to get to is figuring out how we would build something that does the following, and hopefully I can actually play this because I want to pause it at the end. You can see this running, agent.run. It's picked a tool saying speaker search, and it's invoked that tool, actually run it, looked for Tuana's talk, and then picked web search. And at the end, you can see that it says, final answer, Tuana Celik will be presenting, blah, 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 blah. We all know the title. And then finally it says, the weather in Salt Lake City on that day is expected to be cold with temperatures between 1 and 10 degrees Celsius, snowfall and rain, not great weather for Salt Lake City. But you can see that it's picked first a tool called speaker search. So we're going to see what this tool even is and how it runs. And then it's extracted my talk from PyCon event data. And then once it knows what day my talk is, it's decided, okay, now I need to use one of the tools called web search. And what I really want to draw your attention to throughout this talk, actually, is the importance of the first instruction I give these large language models so that they are able to do this. All of those previous ChatGPT screenshots you saw have one obvious thing in common, which is the quite impressive language model itself. But they also have a very well-structured, effective instruction, which we call prompts. So I'm going to be referring to them as prompts from now on. So we're going to be looking at a lot of prompts. And this is really well highlighted by this, why can't I go to the next slide? Yeah, this also Jasper's meme, by the way. This quote by Andrej Karpathy, who said, the hottest new programming language is English. You're going to see how true that is when it comes to how agents are even able to exist. All right, so before we dive into building an agent and seeing how these tools can be described, I want to do a quick introduction to Haystack. So Haystack is a fully open source NLP framework. You can scan that QR code and you'll get to our GitHub page. And it's maintained by my company DeepSet, plus a very vibrant, large community of developers, open source developers who contribute to the project every day. The core idea behind Haystack is what you see on the right-hand side here, which is a pipeline. And it allows you to sort of mix and match components, NLP components that you might want to use depending on what your use case is. A very, very common way of doing a query pipeline is what you see on the left, where you would use a retriever node, which is really good at looking at a really large set of documents and deciding which ones are the most relevant for the user's query, followed by a reader. We're not going to be looking at the reader today, but the reader is basically a component that uses an extractive model. So it only looks at context and extracts answers. It does not formulate a human-like response. And you're able to use models off of, depending on what you want to do, Hugging Face, OpenAI, Cohere, and also decide what database you want. So you can decide to use a vector-optimized database like Pinecone, Weaviate, or you can go with OpenSearch, Elastic, depending on what your tech stack looks like. So the whole idea is really a whole end-to-end NLP application will actually end up needing a lot of tooling around it, a lot of pre-processing maybe, and we try to provide all of the quality of life features that you might need. At the end of the day, this is what a pipeline structure actually looks like. And I'm going to come back to this slide later because you're going to see how this is kind of different to how agents operate. A pipeline is a predefined path made up of components based on what you have decided before, what your application is going to do, what it's going to need. Like I said, a pipeline might look like this, but you're free to mix and match. Let's say you switch over the reader with a generator, so it's a generative model now. You can use Elasticsearch, Weaviate, Quadrant, Pinecone, and decide which models you use for your retriever and your reader or generator based on what you want to achieve. And then you can also expose your application via REST API. So this really covers most of the basics of Haystack at this point. Now I'm going to start talking about where it changes. Again, this is a one-path system. The path is predefined, and your data is walking through that path. All right, so I want to build a pipeline with Haystack, and this is going to be important because we're actually going to use this pipeline later on in the talk as one of our tools for an agent. So you saw that video I showed where it was actually running and doing speaker search and then deciding what the weather was like, doing web search. I have actually crawled the PyCon event page, and this is on Hugging Face. It's a data set. And you can see it's got talks, tutorials, sponsored talks, everything there ready for me to use. I've got two options. I can either create a search application going through a retrieval and then a reader, so extractive model, or I can basically do the same, so I know that my generative model is getting retrieved documents from that data set you just saw there, and I'm going to pick that one. I'm going to use a generative model, because it's just a bit more interesting. All right, so the two components in Haystack that will allow you to interact with large language models with your own data are these two, the prompt template and the prompt node. The prompt template is basically allowing you to create a blueprint of how you want to interact with large language models, and we're going to be looking at how we build our own. And it's flexible because you can actually change what the prompt is at query time. The prompt node is simply basically the connector to these large language models. So this is where we say I want to, use GPT-4 or use Google's FLAN models, etc. And this is the one that interacts with the large language model. So it's the one that sends the query and receives a response. All right, so we saw at the beginning how instructions are important. So I've created my own instruction to do some search on PyCon event data. And here is my instruction. So I'm not sure if this is readable from the back, but I'm going to read it out for you. So I've called it my prompt, and I've said, you will be provided a list of events, reply to the query based on the content of the provided events. And then the next few lines are important because I said query, and then I've given this variable called query in curly brackets, and then I've also said events, and I've said in curly brackets, join all the documents. So we'll see how this works. But basically, these two things in curly brackets is where the magic happens. And at the end of the day, I want to build a pipeline that actually sends the following prompt. This was really long, so I've actually split it into 2 slides. But what's happened here is you can see that my query, what day is the talk about agents and LLMs, has been basically injected into the prompt that I am sending to an LLM in the query section. And you'll see how the retriever has retrieved some documents and joined them. And that's been where I fill the events, the curly brackets that say join events. Again, I've shortened this, there was a lot. And then finally, we are saying, okay, now what's the answer? And we expect an answer from the large language model. So, all right, so how do I make this happen, basically? Well, first, I declare a prompt template, and I've called this prompt template events QA. And I've said the prompt text is what I just created, my prompt. Finally, I've created a prompt node, and I've said your default prompt template, so anytime you get called by default, you use this prompt template that has just been created. And I call this prompt node PyCon QA. And then I just create a pipeline. I say I've got a pipeline, and I add my first node. Let's assume we have a retriever. I did not really want to dive into retrievers right now. But the retriever has access to all those documents you saw on Hugging Face, basically. And the first thing that gets the query is this retriever. So the first job is, first I need to find the most relevant documents, events out there. The second node is my prompt node. The second node is the PyCon QA node that already has the prompt template ready. So it's now ready to receive documents and a query and inject it into the prompt text that I created and send it over. Finally, I ask it the question, what day is the talk about agents and LLMs? And I receive a response a bit like this. It's quite long. It says the talk about agents and LLMs titled, gives the title of my presentation, and says on Thursday, April 20th. I built this pipeline and ran it and then I just wanted to try another query. This was using GPT-4. I'm going to be using GPT-4 for the agents as well. And I asked it the question, I'm interested in NLP, what talks should I see? And I got a pretty good response, actually. It also gave me the correct URLs for every talk. I was pretty impressed, so decided I might add this in here. And everything you're seeing here is basically referred to as a retrieval-augmented generative QA methodology. Another one that I wanted to share because I think it's cool and it gives you the idea of how this works and why retrieval augmentation is important, is this Hugging Face space. You can scan that QR code and try it out. Given the Twitter username, it actually inserts the latest Twitter streams of that user and then gives you the prompt is ready and it gives you an idea of what type of tweets this person tweets about and what languages they use, etc. Okay, now we're back to this slide again because I want to reiterate this. This, again, is a pipeline. I've added nodes. The path is set. Data is flowing from one node to the next, and the knowledge base is also set. I can't ask anything about weather to this application. If I do, the best thing that's happening is probably I'm getting some weird response, complete hallucination. The knowledge base is PyCon events. All right, so this is where agents get in. Also, you can thank Jasper for this. All right, so features of an agent. So what is an agent? An agent is, in essence, a prompt node, that prompt node we were looking at, which connects to a large language model, but most importantly, it's got a very clear, very clever initial prompt. So we're going to look at what that prompt is. It has access to a variety of tools, and these tools actually exist and they run. These tools might be Haystack pipelines, like the one we just built now. They could be other data connectors, the pipelines that have access to a completely different knowledge base. They could even be web search. It's really up to you. The idea is, as well, with Haystack, that people will be able to build their own tools. And this is important, too. Each tool might be useful to achieve one specific thing or have access to a completely different set of data. And again, like we saw in the first few slides, where we said, explain to me step by step how you're going to come to your conclusion. An agent is going to create an action plan to look at a query and say, these are the tools I will use to resolve this query. Some more QR, because these are basically the two papers that the implementation of agents in Haystack is based on. Highly recommend reading them. They are very interesting. One of them is called React, the other one is called, well, it's MRKL, but pronounced Miracle Systems. So if you're interested, please take a picture of that. All right, so we know that what a large language model can produce is really, well, not completely, but it really depends on the initial instruction or the prompt we give them. So what is the prompt we give to an agent for it to be able to do what it does? Well, the default one in Haystack is called the zero-shot React prompt. And again, this is very long, so I've split it into 2 slides, and I'm going to read out the ones that are the most important. Number 1, it says, you are a helpful and knowledgeable agent, and to achieve your goal of answering complex questions, you have access to the following tools. And this is where you see the curly brackets again. So you're going to see how dynamically we can add more and more tools with descriptions. And then it actually tells the model how to think in a way, because it says, use the following format. And it says, first you're going to get a question, and then generate some thought, decide what your next steps should be. Then pick a tool, and we give it the tool names. Then decide what the input to that tool should be. And then finally observe what the response of that tool is. And we tell it to give us a very short answer, but actually it's back there. We ask it to continue this loop until it's reached a final answer. And this is where you'll see how it's starting to become a bit different than the whole pipeline concept. And then finally, we provide a way to input the query to the agent. All right, so an agent at the end of the day, and this is, again, where it starts to differ from a pipeline, is a bit like this. It's always there. Technically, you can define how many steps it should take, because otherwise sometimes maybe it goes on for too long and you're sending too many requests to OpenAI and the bill is ranking up. So you can set that. But effectively, you have this agent that exists that has an arsenal of tools that it can, at every iteration, decide which one it should use or not. So the path is definitely not predefined. The path is defined on the fly by these models who are making decisions about what to use. Another way of looking at this is this. Think of the agent as a loop. At the end of every iteration, it's saying, have I got the final answer? No. Back to another picking tool and creating thought iteration. If I do, great, I can end this. So I created this PyCon event agent. I did change the zero-shot React prompt just a bit, because as you saw, it said, just give me a 1 to 5 word answer. I did not want a 1 to 5 word answer. I also helped it out a bit, and I very creatively called it the zero-shot React PyCon prompt. It's very similar at the beginning. I do tell it to correctly consider the date, topic, speaker constraints of the user input. And I simply just, at the end, tell it to give it as detailed as an answer as it decides. I don't want a 1 to 5 word, very simple answer. And now we're going to look at how we might fill this prompt with the following. So in my prompt, I'm going to define something called PyCon event QA. It's going to be useful for when you need to answer questions about PyCon. Then I'm going to define speaker search. This is, there's a reason for this, because I tried this with just PyCon event QA using a retriever that does embedding search rather than keyword search, which is not great to ask it, like, find me Tuana's talk. Tuana becomes a keyword there, so I ended up defining another one. And then I also have web search, which simply basically Googles your questions for you. And then, again, we're going to look at the query, when is Tuana's talk at PyCon, and what will the weather in Salt Lake City be like that day? All right, so how would we build this with Haystack? First thing, we define an agent. Again, an agent is in essence a prompt, and I provide it with that prompt template you just saw. And I use GPT-4 here. Then, that pipeline we created before, that generative QA pipeline, I say, this is my tool. I call it PyCon QA tool, and I say, give it a name and give it a description saying useful for when you need to answer questions about PyCon. And then I simply add that tool to my agent. Now my agent has at least access to that pipeline, which has access to PyCon event data. The next thing I do, again, because of this keyword search situation, because I really wasn't able to ask it questions about specific speaker names or dates without some keyword search, I won't look into how we built that pipeline, but basically I define another one saying, useful when you want to answer questions about specific speakers, and then I add that, and now we've got 2. And then I can define a web QA pipeline. This is also a new pipeline we have in Haystack. This simply, long story short, can Google your questions and return to you first of all, the most relevant web pages, and then generate answers from them as well. So I define this, and basically I've defined this as my sort of fallback tool, because I've said anything that you cannot answer with PyCon event data, this is the knowledge base you should go to, just Google it. And now I've got 3 tools. And now I can ask this question, agent.run, when is Tuana's talk at PyCon, and what will the weather in Salt Lake City be like that day? And I have an agent that has all the resources it needs to actually answer this question. So we end up with this. Again, it's the same video, basically. And you can now see how it will first I need to find Tuana's talk, and then decide the tool input for speaker search should be Tuana. And then it knows the date of my talk, and it decides that the input for web search should be weather for Salt Lake City, 20th of April. And that is the general idea behind agents. All right, thank you very much for listening. I hope I was able to deliver what agents are and how they come about. If you do want to try building your own agent, the first QR code is a tutorial that uses simply one tool, and it's great at doing multi-hop question answering because of that. And then the second QR code is an article explaining the agent's implementation in Haystack, what kind of tools you might use, and I try to deliver the idea behind agents in this article. Myself and my 2 colleagues and a few more were here throughout PyCon. You can find us at booth 321. If you do want to come and have a chat with us, or you simply want a sticker, that's also fine. But yeah, I hope you enjoyed that. And I guess we have some time for questions now. Yeah.
What are the types of agents you support? And you were making, and with a Python, I can make a custom agent that would query Wolfram Alpha.
Oh, actually, that's a really good question. So there's types of agents and there's types of tools. So I'm going to address those 2 separately. The default one uses this zero-shot React right now, but you can completely build from scratch your own agent prompt. So we do have examples of, so this one is called zero-shot because we actually didn't give it any examples of how to react to questions. There are some cases where few-shot, where you do give examples, works really well. But the idea is, yes, you can build a tool. And I actually think I know a community member that's building a Wolfram Alpha tool for an agent. A tool can be another Haystack node, a completely new pipeline that uses a prompt node or has a separate connection to another API, yes.
I'm leaving line chain, but it's sort of thinking about
Are there any other questions? Yes.
So I think OpenAI API has a limit of characters.
Yes.
So I think it's 4,000 or something like that.
Yeah.
So I'm just curious, can you use other open source LLMs with this?
Actually, I should have referred to this in my talk, so I'm glad you asked this. Yes, so my example was with OpenAI, but the idea is you can use any language model, large language model that can follow instructions. So for example, I know a couple of people who use Haystack agents with the Google FLAN models, and I don't know if we support it just yet, or I think we're looking into it. Quite recently, Databricks came up with Dolly, which is an open source model that, it's coined saying instruction following model. So maybe that will work as well. Yeah.
And sorry, with Bloom, is it something like a Bloom model?
I'm looking at Mattis because he's probably more likely to know the exact answer to this one.
I think, like, technically, yes, there's nothing speaking against it, but there's no, like, good instruction type you're variable to do yet. So you always have to look at, technically, yes, it uses the correct class, you can use it, but does it also work as an agent for the performance one? Okay, so that one was called Dolly, right?
Dolly, yes. Yeah. I think I saw another, yeah.
Oh, thanks.
Oh, nice.
Okay. So you were using OpenAI's GPT-4 model.
Yeah.
If one created their own LLM from using Hugging Face's tokenizer, can they still utilize that with Haystack and build this very streamlined pipeline?
So Haystack already has an integration with Hugging Face. So if it is a model at the end of the day that could follow instructions, that should be possible. For example, the Google Flan models I was just mentioning, we actually just pull that from Hugging Face. It's not it's not.
Does it always have to be pulled from Hugging Face?
No, so we have connectors to OpenAI, Cohere, even though we don't use it specifically for agents, Hugging Face, and you can use all of the Haystack pipelines you saw before. So the pipeline we built with generative QA, for example. You can also simply use a local model.
Okay, so you can build a model, download it into your laptop,
Yeah.
and then run Haystack with it.
Yeah,
Right?
yeah, yeah.
Cool. Thank you.
Yes.
Do you guys have any tutorials on how to make your own tools?
Tools, not yet, but well, actually, technically, that one, you do technically create your own tool. It just happens to be another Haystack pipeline that it becomes a tool. But yes, we are coming up with more examples. There's one coming up that actually creates web QA as a tool as well.
Okay, because I was thinking it'd be really nice to sub in like DuckDuckGo or something as like
Yeah.
the web search instead of like.
Yeah.
I guess you guys are using server, is that it?
Yes, I believe there's also another one too. And yeah, so agents are pretty new with Haystack. We have instructions on how to build your own custom nodes, and people who've built their own custom nodes have found that making that an agent tool has been quite smooth, but we need to add some instructions around that.
Okay, thank you.
There's one over there that I can see.
Hi, I'm studying NLP. As someone in the field of NLP, what would you recommend are things that I could learn? Like tools or things to research?
Honestly, I would say agents are so new that I would really recommend those two papers. I actually have a background in computer vision, funnily enough, so NLP is still quite new to me. But those two papers are the React paper explains this whole reasoning aspect of large language models, and the Miracle paper is very interesting as well. And I would, if you want to build full applications, I would really recommend looking into how tools would be built and which data sources might be interesting for you to build tools that an agent can have access to. Yes.
Have you had any experience or faced building tools using like SQL or GraphQL or more specific querying languages? So like you could integrate with this kind of databases?
Not myself, but I think he has.
So we have like this knowledge graph support in Haystack as well, but we have to honestly say that it doesn't really deliver the same performance that you're used to by now from large language models. But I think there's quite a few language models which are good at language to SQL basically, and that would work in a Haystack pipeline probably as well. So as a tool, maybe a small custom wrapper should work.
I think that's about it. I really hope you enjoyed that. Yes, feel free to visit us in our booth 321. We'll be there until the end of PyCon. It will be really nice to meet you, and yeah, see you all around.